हेलो। स्क्रीन एंड ऑडियो क्लियर है?
यस सर।
ऑलराइट, तो स्टार्ट करते हैं। So in the last lecture we are going this in the last lecture we had discussed about the addressing mode used in 8086 microprocessor, and we have seen that there are 8 different types of addressing mode from where we can find out the location of operand. So first is immediate addressing mode, second one register direct addressing mode, third one register indirect addressing mode, fourth memory direct addressing mode, memory indirect addressing mode, raised, this one is base register addressing mode, indexed register addressing mode, base index register, addressing mode, and last one is based indexed with displacement addressing mode. So these are 8 different types of addressing mode which we are looking for, and in all the addressing mode we are looking for the operand which is given to the instruction. So sometimes operands can be given directly into the instructions, sometimes it may come from the register, sometimes maybe it come from the direct register or indirect register. Similarly, sometimes it may come from the direct memory address or memory indirect address, right? So first one was immediate addressing mode, in which we have already discussed that operand is already given to the instruction. So the addressing mode in which the data operand is a part of instruction itself is called immediate addressing mode. And we have discussed one example how to indicate that instruction contain the operand. Second, we have discussed register addressing mode. It means that the register is the source of an operand for the instruction. And this one the example which indicate that operand is a part of register. Now, in this lecture, we will discuss register indirect addressing mode. Here, the register field from the instruction specifies the address of the operand in the memory. That is the register contains the memory address rather than operand itself. The advantage of using this mode is that less number of bits is required in instruction field address and register rather than addressing the memory. So let's understand this by using a one instruction code. Example, move AX, comma, square bracket, BX. That means go to the address stored in BX and move the content from there to AX. So in the register indirect addressing mode, here the register field from the instruction specifies the address of the operand in the memory. That is, the register contains the memory address rather than the operand itself. तो यहाँ पर जो रजिस्टर फील्ड है, हमें पता है हमें एक इंस्ट्रक्शन गिवन होगा, उस इंस्ट्रक्शन के अंदर जो रजिस्टर की फील्ड होगी उस फील्ड में हमें ऑपरेंड का एड्रेस मिलेगा और वो होगा मेमोरी का. दैट मीन्स इंस्ट्रक्शन फील्ड में रजिस्टर की लोकेशन पर हमें मेमोरी का एक एड्रेस मिलेगा जहां पर हमें ऑपरेंड मिलेगा. राइट. सो रजिस्टर डायरेक्ट एंड इनडायरेक्ट दोनों थोड़े से डिफरेंस होंगे, थोड़े से डिफरेंट होंगे. इन रजिस्टर direct addressing mode, we have given the name of the register where operand is situated. But here we are using the name of register which is in square bracket, and square bracket shows that that is the location of memory. So BX actually contains the address of memory from where we got the operand. So that has to be keep in mind that if any register name or any location uh, covered with the square bracket, that means it indicates some location of memory. So let's make the diagram to understand these things properly. Register indirect addressing mode. This is our instruction. This one is mode bit. This one part indicate the operation code, and this part indicates the address of the operands. In the address of operand, we have given the address of memory. Let's suppose this is the example 4041 hexadecimal notation, or we can say it contains the name of register R1. In our example, we are using the name of register VX. So let's make it BX. So instruction contain the name of register and name of register contain PX contain some address of memory. Let's suppose this is the address of memory 4041 H 4041 suppose, and this is the memory location, and these are number of memory locations over here, and somewhere else the 4041 is pointing in this way. Here is the operand actually, and we are using operation code move. So this is one kind of register indirect addressing mode. What we had written in the theory, the instruction contain the name of register, and the name of register contain the address of the memory, and in the address of memory we got the actual operand. So that is the actual working of register indirect addressing mode. Okay, now there is one advantage of using register indirect addressing mode. It uses the least number of bits. Now why it is said to be? It is using the least number of bits because the name of register is contain the least number of bits as compared to the address of the memory. You know that the address of memory refers by 32 bit, 64 bit, but the length of the register or the name of register will contain only 8 bit or 16 bit maximum. So in the point of memory, it contains the least number of bits. So the advantage of using this mode is the least number of bit is required in the instruction field to address a register rather than the addressing of the memory, right? And move space ax comma square bracket bx. What it indicates, move is our operation code, operation which we are going to perform on the content of bx content. So go to the address is stored in bx. What it instruction says, go to the address is stored in bx register, which is the length of 16 bit, and move the content from there to ax register, which is again a 16 bit register. So ax is nothing but a accumulator register. Bx is base register. So this one is register indirect addressing mode. So immediate addressing mode we have done. Register direct addressing mode we have done. Register indirect addressing mode we have done. Now we are looking for memory direct addressing mode. So let's discuss on it what kind of addressing mode it is and how it works in 8086 microprocessor. Now in this mode of addressing, the effective address is equal to the address part of instruction. here the operand resides in memory, we directly get directly get the address of the operand from the address field of the instruction. Now let's understand this theory by example. Suppose the operation code which we are going to perform on the content of register or the content of the memory operand is move. Here we are using the low part of accumulator register which contain only 8 bit from 0 to 7. So move space AL, and here we are given directly memory 0400. Let's suppose it is a hexadecimal notation. So whatever the content given to the square bracket, it indicates it is the address of memory. First thing that we have to keep in mind. And if it is given directly, that means it indicate directly operand. So we are referring the memory direct addressing. So here should be the address of operand given to the memory. So move AL comma square bracket 0400H. Now let's drawing the content. So move, here is AL register. Okay. Now this is the address of memory. So we have to design the address of memory 0400. So this one is 04. This location will be 0400, and these memory locations contain the operand. So this is the address of operand and this is the memory reference. Now here is not required the name of register because we are not discussing about the register addressing mode. This will also removed from the instruction, and we are discussing memory, direct memory addressing mode. So here will be the name direct memory addressing mode. So in the instructions we have given the address of memory 0400H, and in this memory location we got the output. We can point this address in this way. So this kind of addressing is called direct memory addressing mode. So let's recall the things, then move ahead. Direct memory addressing mode. In this mode, the effective address. Effective address is from the operand is situated. That address is called effective address. So in this mode, the effective address is equal to the address part of the instruction. Operand itself in the memory, we directly get the address of the operand from the address field of the instruction. And this is the example which shows direct memory addressing mode. So we have done memory direct addressing mode. Now memory indirect addressing mode. So let's understand here. The address field of the instruction gives the address where effective address is stored in the memory. Here, instead of getting operand from the address field, field of the instruction, field of the instruction, we again get effective address of operand. For example, let's suppose move. Uh, we take the same example. 0400H. Again, we are using the 8-bit register, accumulator register, and instruction contain the memory address. So let's draw the things. This is our instruction, 16-bit instruction. This one is mode bit, opcode, and address of operand. Now the instruction contain the address of memory. So let's suppose 0400H is the address of memory. So we are using lower bit. So we have to remove these things. We are using lower bit. So it will contain only 2-bit. Let's suppose 45H. This is the location. 45. This is the memory location 45H. And if we go into this memory location, we are not getting directly operand. That means we are not getting effective address directly. What we get we get another address. Let's suppose 49H, and this memory locations, let's suppose somewhere else, 49H, and in this memory location we got the effective address. So this is the 49 number location from where the operand is actually situated. Is operand. So this is the actual meaning of indirect memory addressing mode. Indirect memory addressing mode, right? So according to this, we can contain the 45H. In the above example, we are using lower bit, so we have to use only 8 bit. Issue, we can use directly X, no issue. 16 bit. So above example is okay for 16-bit register. 1 bit contain the 4 bit, so 4 digit contain the 16 bit, right? Here we are using 8-bit register, so we have to contain only 8-bit content. And this diagram shows the actual working of indirect memory addressing mode. So instruction itself contains the address of memory in the address of operand part, and if we go to the address of memory 40 location, we got another effective address, and if we go to 49 location, we got the operand. So this is the way how to get the operand by using indirect memory addressing. Okay, next one is this register addressing mode, and as far as the name is suggest, we are getting the effective address by using the content of base register. So in the instruction we have given the address of base register. We have to add these address contained by the base register to get the effective address. So let's write the definition. In this addressing mode, in this addressing mode, the effective address of the operand is given by the sum of contents of base register, that is BX, or if there is a pointer given into the instruction, that means base pointer, register, and 8 oblique 16 bit displacement. So effective address is somewhere else. It will get after adding the content of the base register. So base register content a proper address. We have to add this address with proper displacement. Then we got the effective address. Let's take example. Suppose we want to move the data from we want to move the data to the DX register, data register, and the address of the operand is given in this way. That means the content of base address with some displacement. So BX, let's draw the diagram. Base register, okay. So here base register addressing mode. That means in instruction we have given the base address register location. Let's suppose this one is 45H. In this case, we have given the BX. So in the address of operand location, we have given the name of register. So let's suppose this is the name of register BX, and this one is not a memory. It is a register sets, which is internal register set for the CPU, and it contains number of registers, and from number of registers there is a register there is register name BX, right? So BX contain the address with some displacement. So here will be a displacement of 4 bit. So from this memory location, this is the base address, 49H is the base address, and we got 4 displacement, right? Let's suppose 1 bit displacement, 1 bit, suppose 2 bit, 3 bit, and this one is 4th bit. So after performing 4 bit of displacement, 4 bit displacement, we got the effective address of the operand. So this is the way how base register addressing mode works. So in short, in instruction, we have given the name of register, which is a base register name, the name of base register. It contains the base address of the register. If we go to the base address, we got a number of displacement bits. For example, 4 bit displacement. So we get the effective address of the operand after adding the 4 bit with base address. So if we add 49 plus 4, we get the effective address of the operand. So here effective address will be get after एडिशन, अब इसका एडिशन होगा, सो एड्रेस ऑफ बेस रजिस्टर प्लस displacement, or we can say offset, right? So 4 bit is like a offset and 49 is the base address. So this is the base register addressing mode. Now next is indexed register addressing mode. Now in the previous base register addressing mode, we are adding we are adding the content of base register for getting the effective address. In the same way, in the index addressing mode, we are getting the effective address by adding the content of index register. So let's write the definition first. Index register addressing mode. Here, the content of index register is added to the address part of the instruction. Address part of the instruction to obtain effective address. And index addressing mode mostly used with arrays. Address of the first item of the array is stored in index register, and to go to nth location or to go to nth item of array, the address field of the instruction contain the value. Hence, n plus value of index register give address of nth item of the array directly. It also requires less number of bit as compared to address the entire memory address. So index register addressing modes. Here the content of index register is added to the address part of the instruction. So in the instructions we have given some address, and this address will be added with the index register to get the effective address. Index addressing mode mostly used in array. That is important things about the index addressing mode, because we know that array, the name of array pointing to the base address. So if we get the base address, then we can approach any number or any item given into the array. So address of first item to the array is stored in the index register. The address of first item in the array is stored in the index register. And to go to the nth item to the array, we have to add these values with some index register content. So n plus value of index register give the nth item of the array directly. It is also required less number of bits as compared to the address of the entire memory address. That is the benefit of using index addressing mode. So this is the diagram. Let's convert it into the index register addressing mode. So index register addressing mode, in the instructions we have given the number of offset bit which will be added in the source index or destination index. There are two type of index register: source index and destination index. So let's write first example, then we can design graphics for that. So move bx comma source index plus, let's suppose the offset value is 16. So this is the address of, so in the instruction we have given two things. Source index with 16-bit displacement. So here will be name of register which is source index register SI, which point in the register set somewhere else. Let's suppose the base address or a source index address is 49H. Now after performing the total 16 displacement, this is let's suppose the 16-bit displacement. After adding 16 with the base address of source index register, we get the effective operand, or we get the effective address where the operand is located. This is suppose total 16 number of bits after 49, sorry. So here effective address will be get after addition the address of index register plus displacement of 16 bit. So according to our example, 49 plus 16 is equal to 64. 65. In 65 locations, we got the effective address of the operand. We get the effective address of the operand is 65H. So if you go to this address, we get the operand. So that is how the index register addressing mode works. So in the instructions, we have given two things: the name of a register, that is source index register, or it may be destination index register, plus displacement. So we have to add this displacement with the content of source index register. Then we got the effective address of the operand. Now the next one is, let's recall what we have done. We have done the base register addressing mode, indexed register addressing mode, base index register addressing mode, right? Now let's write the definition of base index register addressing mode. Now it is clear that in the instructions we have given two things again: the address of base register plus the address of index register. We have to add the content of both the register and we get the finally effective address of the operand. So let's write the in this addressing mode. In this addressing mode, offset address of operand is computed by summing the base register to the content of index register. Then we get the effective address of the operand. So in every addressing mode, we are looking for the operand. So one thing you have to keep in mind, we are always looking for operand where it is located in the memory or register. So there are certain number of techniques by using we can find the effective address of the operand. So let's the example. Uh, for example, we are using instruction add cx comma square bracket ax plus si. So what we are doing here in this given instruction, we are performing the addition. After calculation the content of registers, we are transfer the content to the cx register, that is counter register. Length of counter register is 16 bit. AX is accumulator register of length 16 bit and source index register, right? We are adding the content of accumulator register and the source index register. After combining both the content of register, we are transfer the value in CX, and whatever value stored in the CX, it will be added up by using the add instruction. So diagram will be as it is. You can understand and design by yourself what would be the graphical representation for the given instruction. And last addressing mode is based indexed with displacement addressing mode. And this one is a last addressing mode. So let's write the definition first. In this addressing mode, the operand offset is computed by adding each register content of index register, and one more thing will be added to get the effective address, that is 8-bit or 16-bit displacement. And displacement is nothing, just offset values which will be added after adding the address. So 8-bit or 16-bit displacement plus the content of base register and the content of index register. All the three things will be added. Then we got the effective address of the operand. And let's take one example which shows that how index base index with displacement addressing mode works. Suppose we want to move ax square bracket bx plus, let's suppose destination index register di, and suppose 8-bit of displacement. So here we are using two register, base register, destination index register, and some displacement. So the content of base register and the content of destination index register will be added on. Then whatever the result we got, it will added with the displacement bit. Then we find the effective address. Here bx is base register, which contain the base address of memory. So square bracket, that means it is pointing to a memory locations. So bx is the name of register which contain the base address of the memory. Di is destination index register which contain the address of index, which contain the address of index, or we can say it contain the index of a particular item. It may be an item located in the array itself. This contain the address of index value or index, and 08 is displacement values. That means after certain number of bits we get the effective address. So a certain number will be pointing as a displacement. It will be referred as a displacement. So 08 is the displacement bit. After adding all three registers, all three values, we got effective address of operand. This is how the based index with register addressing mode, based index with displacement addressing mode work. सो ये थे हमारे एड्रेसिंग मोड जो 8086 माइक्रो प्रोसेसर में यूज होते हैं। इनसे हम केवल एक ही बात क्लियर करते हैं कि हमारा ऑपरेंड कहाँ से आ रहा है। उसी ऑपरेंड के बारे में कंटिन्यूसली हमें इफेक्टिव एड्रेस बनाना होता है, और उस इफेक्टिव एड्रेस को बनाने के लिए एटलीस्ट हमारे पास 8 से 10 इस तरह के एड्रेसिंग मोड होते हैं। सो इसमें से कोई भी एड्रेसिंग मोड टाइम टू टाइम यूज हो सकता है। कभी ऑपरेंड मेमोरी से आ रहा है डायरेक्ट इनडायरेक्ट में, कभी रजिस्टर से आ रहा है डायरेक्ट इनडायरेक्ट के केस में, कभी वो स्टैक से आ रहा है, कभी वो अरे से आ रहा है। तो इन सब सिचुएशन के बेस पर हमारे पास इतने सारे एड्रेसिंग मोड होते हैं, और ये एक इम्पॉर्टेंट टॉपिक है, इसे आपको अच्छे से प्रिपेयर करना होगा। एग्जाम पॉइंट ऑफ व्यू से ये एक इम्पॉर्टेंट टॉपिक है, सो यू हैव टू कीप इन माइंड, ये अच्छे से तैयार करना है, राइट। सो यहाँ पर हमारी यूनिट 3 फिनिश होती है। नेक्स्ट लेक्चर में हम लोग स्टार्ट करेंगे यूनिट 4, विच इज रिलेटेड टू द ऑपरेटिंग सिस्टम्स। सो हमने जो डेमो लेक्चर रखे थे, टोटल हमने 6 लेक्चर डेमो लेक्चर में रखे थे, सो वही कंटेंट है। आप उसका एक बार ब्रीफ करें तो आपको और अच्छे से क्लियर होगा। सीपीयू शेड्यूलिंग के बारे में हम लोगों ने डेमो लेक्चर रखे थे, राइट। सो उसको आपको एक बार ब्रीफ करोगे तो आपको नेक्स्ट लेक्चर जो यूनिट नंबर 4 है वो आपको अच्छे से क्लियर होगा।